Hi, my name is Elizabeth and today we're going to be going over atomic orbitals. So before we talk about atomic orbitals, we have to talk about the principal quantum numbers, which I kind of have laid out here. We have n, l, m sub l, and m sub s. So n is going to be your principal quantum number, and that's just going to be found on the period where your element in question is found. By period, I mean on your periodic table, you have columns and you have rows, right? So columns are the ones that go up and down, while rows are the ones that go left to right. So if you notice, you're going to have the first two columns, your transition metals, and then you're going to have your block over here as well. So on the sides, you can number each of your rows. So you can do like 1, 2, 3, 4, etc. Those are also going to be, you can say that those are going to be your principal quantum numbers. So that's a very easy way to be able to find your n value. Notice that it's going to start at 1 and it's going to end at, I believe, around 7. 7 is going to be your last number. Now, L is going to be your angular momentum. So L is very special because for every shell, it has a specific value. So we have 4 types of shells. We have the S shell, P, D, and F. And these are also very easy to find on your periodic table. The first 2 columns, so the first 2 up and down ones, are going to be your S block. So anything found, any element found in that block is going to be in the S block. Anything in the block right over here is going to be in your P block. So that's going to be where your nitrogen, oxygen, carbon, and your noble gases are found. Your D block is just going to be your transition metals. So anything found in there is going to be found in the D block. And then your F block is those random 2 that kind of come out of the periodic table and no one ever talks about them. That's going to be your F block. So for your L values, for S, L is always going to equal 0. For P, your L is always going to equal 1. For D, your L is always going to equal 2. And for F, your L is always going to equal 3. So this is very important to remember because this is a dead giveaway. If you know that something is n equals 1 and you know that in n equals 1 there's only S, then L cannot equal 1, for example. So it's very important to memorize these. So it's just 0, 1, 2, 3, S, P, D, and F. All right. Your M sub L is going to be in the range between positive L and negative L. So for S, your M sub L can only equal 0 because positive 0 to negative 0 is still 0. So for P, your M sub L has to be found in between negative 1 and positive 1. For D, your M sub L has to be found between positive 2 and negative 2. And for F, your M sub L has to be found between negative 3 and positive 3. Anything outside of those ranges is not possible for any of these orbitals. And then your M sub S, this was my favorite for whatever reason. It's just the spin of the electron, and it can only spin in a positive manner or a negative manner. So it's positive 1/2 or negative 1/2. Those are your only 2 values that can exist for your atomic spin. All right, so now that we know those a little bit, we can study these and see what is wrong with them, if anything is wrong with them. All right. So here we have n equals 1. That is possible because the range is from 1 to 7. So this one is fine. L equals 0. So we just look at our periodic table. In the n equals 1 column, is there an s orbital? And we would find that yes, there is. So that one is fine as well. Is m sub L equals 0 between 0 and 0? Yes, right? So that one is also fine. M sub S equals positive 1. Notice that M sub S can only equal positive or negative 1/2. So this one is incorrect. This has to be positive or negative 1/2. So this is the problem one. Let's use that same kind of thought process for the next one. So n equals 1, that exists, so that's fine. L equals 3. L equals 3 is the F orbital. That's nowhere near n equals 1. So this one is incorrect. Also, L has to be n minus 1. So the maximum number in n equals 1 would be 2. So this is incorrect. So it has to be less than or equal to 2. So this one is wrong. Let's keep looking to see, right? So if, let's say it's still theoretically L equals 3, M sub L could equal positive 3 because that's within the range, and M sub S equals positive 1/2, that's fine because that's one of our options. So for our next one, we have N equals 3, that exists. L equals 2, N minus 1 is 2, so that's fine. M sub L equals positive 3. Let's think, is that in between -2 and positive 2? No, that's beyond our scope, beyond our range. So this would be incorrect. It has to be in between this range, and it's outside of the range. And M sub S equals -1/2, that's fine because we only have 2 options. You see why M sub S is my favorite? Because it's just so easy. It has to be positive or -1/2, and that's it. So let's look at the very last one. N equals 0. Is that between 1 and 7? No. So that's automatically the one that's incorrect. It has to be between 1 and 7. L equals 1 does exist, and it would be fine for 0 to be in there because -1, 0, 1, right? That's what would be fine. And then M sub S equals positive 1/2. That would also be correct. So the one that's incorrect here is N equals 0. So that's basically how you can use the principal quantum numbers to be able to realize which one is going to be incorrect in a given set. This is a very popular test question. So I would, if you don't understand it the first time, I would re-watch the video to make sure that you really understand it because it's a very popular test question. So if you have any questions, just let us know.